Hello, everyone. Welcome to this new episode of the Swift Academy podcast. Today, I'm very happy to be with Michael Long. Michael Long is an iOS expert developer from many number of years. I have the pleasure to be with him today to speak about a great topic that I liked very much, which is dependency injection. Michael is the creator of two frameworks for the iOS community, such as Resolver and Factory. Hello, Michael, and how are you?
I'm doing great, and it's nice to be here.
Okay, thank you. Maybe people that didn't know about you, if you can make little presentation of your great career as iOS developer and software engineering. Can you maybe make a small presentation of yourself? What kind of topics that you are interested, and that's all.
Okay. I've been doing software for quite a while. I've been
Okay.
doing software on quite a few platforms, from mainframes to mini computers to desktops to servers and so on. But about, I don't know, for the last 12 years or so, I've basically been doing iOS development.
Okay.
And that's largely been in the financial space. And so I've been working on banking applications. And I was just on a team that helped one of the major U.S. Trading companies like totally rewrite their and re-architect their trading application.
Okay, great. It's a little presentation, but for me it's a good, it's a good one. What do you like? Maybe we can dive into the topic, our main topic, which is dependency injection. Um, the first question: what's your vision about dependency injection as a pattern, and also why it's important now for our iOS developer community?
Okay. Um, Basically, we've had a long road where we sort of threw applications together, and we had, UI view controllers and whatnot. We put all the logic in there, and we figured out that was a bad thing, and so we
Yes.
started trying to split our applications up. And we sort of grew up a little bit and started trying to, do more solid kind of things and have separation of concerns and
Mm,
breaking our application into little pieces so that this handled networking and this handled analytics, and my view model logic did this part and so on. So we take our application, we break it up in all these little pieces, which is a
yes.
good thing. It makes them easier to read about and easier to understand. But when you do that, eventually you have to take all those little pieces and put them back together again.
Yes.
So you need
Yes.
some way of wiring your application together. And that's where dependency injection comes in. It's basically giving something what it needs to do its job.
Mm. And for people, the definition of the pattern is that it's not the responsibility of the client to create his dependency. Uh, we should inject the dependency, and we delegate, if we can say it, the creation of all the dependency of our instance, classes, struct, etc., to another component, maybe something in the MVVM uh, pattern, what we call coordinator. In this part, we create the instance, etc., and we inject in the constructor or using property, something like that. But after that, there is what we call DI container framework that come to make this stuff to create instance to create instance, and also the difference, what we call dependency of this instance. And for your point of view, why we need to have this kind of what we call DI container? Why we need to have uh, we can make dependency injection without using what we call DI container.
So there's a bit to unpack there.
Mm,
Um, so with most of the time when people start talking about dependency injection, that's constructor injection, And that's
Yes.
basically when I create the object, I give that object the things that it needs to do its job.
Yes.
Um, and that works to a certain extent. One problem that you have with that is it sort of kicks the problem down the road, uh, because whoever made my object now has to know about all of the things that it needs to give to me and where did it get those things from. So there's that to think about. Another was that if you take like a modern application, modern applications can be kind of complex.
Mm.
And yes, I can have maybe like a view model that manages a screen, and that's good. But that view model may need to talk to a networking service, so I've got to inject that into it. And then it also may need to talk to an analytics service to register
Yes.
user events and so on. So I have to give it one of those. It may need to talk to a cache and repository so it can store information. So I have to give it one of those. I may be doing A/B testing of some sort. So I have to give it whatever interface I'm using to do A/B testing.
Mm.
And now my constructor starts looking kind of bad because I have to give it A and B and C and D and E and F and G and so on.
Yes.
Um, People would say that you would want to start trying to break those things apart, but sometimes you just can't. I mean,
Mm.
it needs to have that logic. It needs to know about the analytics. It needs to know about users. It needs to, and so on. So you can give it all those pieces individually, or you can take all of those pieces and wrap it up in what we call a container.
Mm. Yes.
And basically say, here's the thing that has all the stuff that you need, grab it.
Yes. Container is like it's like a container with the different instance that exist in our application, but it's not not only the container. There's what we call the graph dependency between this instance and the relationship between the dependency that we will discover later in our discussions. And maybe that come to the question: what is the reason that you have created two framework for dependency injection, resolver
Okay.
and factory?
In
What?
fact,
Yes.
so a long time ago, when I first started in iOS development,
Yes.
um, we started doing a greenfield banking application, and that was in Swift 2.0. And we
Okay.
had like a free hand to kind of pick and choose the things that we wanted to use for this application. And so we decided the architecture was model view model, and we decided we were going to use RX Swift. And then we decided that we really needed some sort of dependency injection for kind of like the reasons we talked about.
Yes.
So we went and grabbed a product that we found called Swinject. And
Yes.
Swinject was actually Swinject Storyboard, because you could use it with storyboards and it injected
Mm.
things into the view controller. And it was kind of a cool product. The only problem with Swinject is Swinject was clunky. Um, the definitions that you had to use to set things up were verbose, and you
Yes.
had to explicitly define all the types and so
Yes.
on both sides. And it just made it was writing a lot of extra code that was boilerplate. And I hate writing boilerplate code with a passion. I
Mm.
just, if I can avoid that sort of stuff, I want to do it. So with Swift had this thing that called type inference, where you could basically infer the type of something based on the usage, right?
Yes.
So if I passed a parameter into something and that parameter was type uh, network service,
Mm.
then I could infer that type.
Yes.
And so basically I tried to improve on Swinject using type inference using a Swift-based library.
Okay.
And also Swinject was Objective-C at the time. So I wanted something that was pure Swift. And so that's how Resolver came into being, because that was my attempt to simplify the code so I could get rid of all the boilerplate and just do as little as possible.
Okay.
And that worked out pretty well. A lot of people use resolvers, but a lot of applications. Resolver won an open source peer award from Google. That was kind of a cool thing.
Mm-hmm.
But when I was using it, and one of the complaints that people sort of had about Resolver was the fact that Resolver is not compile time safe.
Yes.
So usually that's not a problem because most dependency systems work by
In runtime.
registering a set
Yes.
of things. I need a
Yes.
network service, so here's the network service you're going to use. I need a analytic service, so here's the analytic service you use. So you
Yes.
register all those things up front when you launch your application, and then you ask for them later on.
And
If
there
you
is.
forgot to register something and you ask for it and it's not there, your application has a tendency to do bad things like crash.
Yes.
And people don't like that.
Okay.
So that's usually not an issue too much because usually when you test your application goes boom and you look to see, oh, well, yeah, I forgot to give it,
Yes.
I forgot to give it the analytics service. I forgot to define that.
Mm.
So, but I still wanted to look to see if it was possible to do something that was compile time safe.
Mm.
And at that point in time, SwiftUI had just been released. And I also wanted something that used a little bit more of the SwiftUI metaphors and worked better with that product. And so that's when I came up with the idea for Factory.
Okay.
Because Factory basically uses a container that you have to register things to, and you talk to the container. And if you haven't made the definition in the container, then you can't link to it and it won't compile. So what you want has to be there in order for the whole thing to work, which
Okay.
makes it compile time safe in most cases.
Mm. But you are not safe to have some crashes in right time because you can, if you can you can check that maybe you miss it to have some dependency when you resolve your instance, and at this moment you have a crash. What the difference between factory and resolver in this part? Because in my comprehension of how it works from the difference between registry and resolver, the registry, we create what we call the structure of A depend of B, C, D, B depend of C, D, I, etc. And in the resolve, maybe the resolve, it's usually in runtime that we detect the problem. What is the difference in factory compared to resolver or swinject or any other DI container in this part? Because I didn't
Okay.
understand very well.
All right.
Yes.
So in Factory, I define a container,
Yes.
and then I define a variable on that container that's
Yes.
going to give me what I want. So analytics, here's my analytics service. And
Okay.
there's a function, a factory function that's in there that creates what I need and
Yes.
returns it.
Yes.
Okay.
Great. Yes.
So when I compile the application, when I give that container to something, I look at that and say, hey, variable, give me what I need. And it gives it to me. So
Okay.
if that variable wasn't there, I couldn't ask it for what I needed because it wouldn't be there. My code wouldn't work.
Okay.
In traditional systems and like Resolver,
Yes.
you basically have some function, and that's usually not quite dependency injection. That's usually called like service locator, because
Mm.
I go out to something and I say, hey, I know you, give me what I need.
Oh, okay.
But basically, you just give it a type and say, give me my analytics service.self, and that's what I want.
Yes.
But I could ask it for anything.
Mm.
I could ask it for anything that I haven't registered. I could ask it for an int.self, or I could ask it for a UI view controller.self or something. So if I
Okay.
haven't registered that thing, it's going to fail because it's not there.
Okay. 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 I understand much better the factory compared to swinject or resolver. Great, great. I understand your motivation. It's for me. It's very important to understand why you try to develop this kind of dependency injection framework. And this question compared to the Android community, which Google offer two frameworks for dependency injection, like Coin and Dagger. And why do you think that Apple didn't have this, uh, if we can say it, native framework for dependency injection, and like other framework, it's usually the community that created this kind of framework. What what do you think? Why Apple doesn't have the same? It's not only for dependency injection. There is also for a problem of architecture, etc. When you see the documentation about for Google to explain clean architecture, etc. In you see the big difference between Google and Apple in this kind of documentation. There is a lot of tools that didn't exist in Xcode that people, I think that a lot of developers think that compared to Google, we have not the same intention from Apple to this kind of tools or framework to develop.
Okay. Um, I can say basically, and I don't know why Apple never did it.
Yes. Okay.
Okay. Although I take this back, they have done a system that's now part of iOS 18 or so. But they set it up only for communication between the application and app intents
Okay.
when you're doing like Siri things and whatnot. So there's a rudimentary system baked into it, but you can't use it for anything else.
Mm.
Okay. So backing up. Back in the dawn of time, um, Apple decided that we were doing basically MVC, model view controller type applications. And given most of their examples and given what most people did at the time, most people put their code some people put the code into some of the views, but most people put it into the view controller. And so there simply weren't all these pieces that we're trying to wire back together again.
Yes.
And a lot of the things that they used take like URL session. They were very fond of using singleton style
Yes.
global variables to pass things around. And so, I talked to URL session.shared, and that's how I got my thing. So there was nothing I needed to inject.
Okay.
And a lot of developers just sort of saw that and think, hey, well, that's how you do it. And so that's how it happened. Android, I mean, yes, they had some, like, in Dagger is kind of a cool thing. Dagger is actually a compile time system. So it basically analyzes thing and wires stuff together based on annotations in the code. And that's actually one thing that I tried to do a little bit more with Factory, in that I kind of view the property wrappers that Factory can use as
Okay.
annotations. So it's sort of like when you say main actor on something now in Swift, you annotate
Yes.
it with that little tag.
Yes.
That's the same that I did with Factory when I say property injected. So it means that this is coming from somewhere else and you don't have to worry about it.
Yes. Yes.
The problem with injected is that basically behind the scenes, it's talking to a shared variable.
Okay.
Because that little property wrapper has to know where to get something. And so it's got like a shared container that this stuff is defined on. That works very well when you're testing your applications, but these days that can start to be a problem, especially since Apple started doing their new testing framework.
Okay.
Because their new testing framework is multi-threaded by default. It
Okay.
wants to run tests simultaneously.
Yes. Yes.
And so if I go to my networking code and say, here's a mock that returns a user, and I run a test looking for a user, but then I've gone to another piece of my code and said, hey, here's a mock that returns an account,
Okay.
and
Maybe we
both of
have
these tests are trying to run at the same time, you can start getting into conflicts.
data races, something like that.
Yep.
Okay.
So that's why I've actually started looking at yet another way of doing this. And I've got a new open source project called Navigator that's a navigation system. But
Yes.
as part of that system, I've been playing around with a new container-based library that if you use it, you don't really run into the same sort of problems that you have with multi-threaded applications going around. One thing that's also good for is that when I used shared globals and shared variables and shared containers and so on, that works well if I have a single instance of my application running. If I support like an iPad and I support scenes, and I could have like two instances of my application running at the same time, then there could also be conflicts between shared state. If I'm expecting, if for example, I set things up so that I have one scene where I logged in as one user and another scene where I logged in as a different user, just as an example. So that's kind of getting out there, but this is something that you have to start worrying more about these days. Especially now that we also get into the new things with Swift and Swift concurrency and sendable instances and so on, because people may have noticed it's a lot harder to start working with shared variables and shared state.
Okay.
You try to start doing static vars and whatnot, and it will start complaining to you.
Yes. Yes. And okay, I understand. First of all, why Apple? Okay, I'm not convinced that Apple. I'm not convinced that why Apple. It's usually focused on MVC, like pattern to create, because I think that there is a lack of something that Apple focus on complicated application, and I think that in the video of the WWDC usually we have some simple example of the new API. So usually some special, but from the point of view of architecture, there is like compared to Google or Microsoft, we are focused on complicated architecture for the mobile application. I think there is maybe Apple should focus or create some tools and some maybe things like Dagger or Coin for the community. We know that we are satisfied with solution like factory resolvers, inject, etc. From and there is a lot of great application now in the production using factory or resolver or swinject that millions of people use it to in their application. And
Yeah.
if you want, maybe there is some concepts that we need to understand that we find them this concept or technical terms in every DI container framework, something like resolve, register, scope, the different kind of scope, etc. And when we prepared this episode with you, we have a lot to speak. We spoke a lot of different kind of scope, management, and why we need this kind of scope in every DI content framework from your point of view. There is some scope. Generally, we have, for my point of view, for my understand, there is singleton, the shared, something that this instance that it shared, or the unique instance that we called in Swinject, or I think in factory transient scope. This is the new scope, the new instance created every time that we resolve we resolve the type. Maybe we can you can present this kind of what we mean, but by register, by resolve, the different kind of scope, because I think that there is a lot of people that didn't understand the difference between register, resolver, scope. What when we use it, for example, the graph scope, the shared scope in factory, etc.
Okay. So part of the whole thing about scoping is that
Yes.
that's something that really happens behind the scenes,
Okay.
right? So for most cases, if I am the service, if I ask for an injected service, I want an instance of that service so I can use it, and that's it. So that's I want what I need and give it to me and we're good.
Okay.
So that thing goes out and resolves that request and says, give me something so I can give it to him. And so he's good. So he doesn't know that it's a singleton. He doesn't know that it's a shared state. He doesn't know that it's been cached. He doesn't know. He doesn't care. He just wants what he needs.
Okay.
Okay.
Yes.
So you back up a level. As the person that's supplying them with something, I have to know what to give them and how to maintain it. So if I'm using a analytics library, as an example, I typically only want one analytics library per application, and I want only one instance of that. So however I construct that thing, I need to make sure that I'm only giving out one copy of it. I want to give out the same copy every time someone asks for it. And so that's like a scope that I call singleton, and a lot of other DI systems called singleton. The exact opposite of that is simply unique, or wherever else they tend to call it, where basically every time I say, give me something, it resolves a new instance of it and it gives it to me. Good example like that might be a view controller, if you're going to use those with
Yes.
the DI, right? Because if I push a view onto a stack and it asks for its view model, and then like if it's a recipe thing, now I click on something and now I put another instance of the same thing onto the stack. So I want to look at a different ingredient. And so now that's out there, and I keep doing that. So every one of those view models wants to be unique.
Yes.
I want a fresh copy each time.
Yes.
So that's the two
Main
primary
scope.
things there.
Yes.
But then there's some gray areas in between. So in factory, there's one called cached. And basically that instance is cached to that individual container.
Okay.
So I can say, I'm going to give you one of these, and then for as long as this cache is, keep giving me the same one. If I give someone else a different container, they can ask for it, and they'll get their own set of instances from that that's all the same. So that works out well for things like we just talked about before, about if I'm doing iPad applications and so on. Another one is shared, and shared is just sort of a funny one. If I don't want to worry about managing the cache, right? So I don't want to come back to the cache and say clear it. But I might want to get the same instance of something in a certain circumstance. So a good example of that is if I'm doing a multi-step bill payment system where I say, here's a screen that gives me, I select my from account, and here's the screen that says, give me my to account, and here's a screen that says, give me my date that I want to pay, and so on. And I've got like maybe this payment object that's out there that wants to be shared between each one of those. So I want that object, that shared object, to exist for as long as the screens that use it exist. And then when that transaction goes away and all those screens disappear, I want that shared instance to disappear.
Yes. Okay. And in Factory, you have this possibility to delete, for example, an instance in the life cycle. Sometimes you need to delete some instance. Compare it, for example, to Swinject, that you can do that only by using what we call the custom scope. Create a custom scope for an instance or kind of list of instance, and if you want to reset all this instance for some reason, you can reset what we call the custom scope. In Factory, you have this possibility to reset specific dependencies, specific instance, or not, because
Yeah.
sometimes I have this issue, especially when we have to in our application when I work. I need to delete every time that I will reload the application, especially when I go to from a market to another market. It's an e-commerce application. I need to delete this kind of an instance, and for that I create, using Swinject, what we call the custom scope. And every time that I disconnect the user from to go to another market, I need to reset this specific instance. I don't know if in Factory or Resolver there is this kind of possibility to go to the container and to go to the instance and to delete this instance.
Definitely. You can do it in both of them.
Okay.
And that example is actually in the sample code. Typically, like if you envision like maybe a session, so like
Okay.
the user logs in, and I
Yes.
want certain things cached for that user,
Yes.
and then when the user logs out, I want to clear that session. So
Yes.
when I log in again, I start all over.
Yes.
So it's pretty easy in both of those to simply define a new scope type and call it session and give it the kind of cache that you want, and it will just
Okay.
do that.
It's a custom scope like in Swinject,
Yep.
like some. Yeah, okay. I understand, because we have development in our company, something that we don't, without using a custom scope, you can access to the instance in the same container, in the main container, shared container, if you can, and you can delete it. But this kind of solution, um, we have a lot of problem, especially when we have with data races, etc. And at this moment, because we have two cached two container, what we call the cached factory for this kind, and a sample container. And at this moment, we decide to uh, to not use anymore our native DI container application and go to Swinject. I didn't have any knowledge about Factory at this moment, because I didn't know about Factory, and maybe we have to check how Factory do things, and we can move so on to Factory instead of of Swinject. But I understand now. This is the same. The same. We need to use what we call the custom scope. And this is my question. Custom scope. when we need to have what we call a custom scope, this something that is not shared, unique, etc.
Um, you can. Okay, I mean, mostly in factory,
Yes.
it's when I talk about a custom scope, I'm sort of talking about a separate instance of a
Okay.
cache, right?
Okay.
So I
Yes.
want here's the cache, but I want a separate cache called session, and I'm going to use session for all the things where I'm getting my user information from, right? So I'm not building a custom scope type. I'm just here's a separate instance of something that I can use for caching purposes. Um, I can't think of a custom. Well, okay, I started to say that, and then I just thought of one. So maybe I would like to have a custom scope type that persisted items to disk.
Okay. Okay.
Um,
But people.
so, I mean, there's a protocol inside a factory that's what a scope is supposed to look like. So,
Yes.
you probably could write a scope that persisted something to disk and just use that one
Yes.
as long as you
Yes.
provided an instance of it. Um, in most cases, though, you don't want to get to that level. And um, a lot of times, too, you have to start worrying. A lot of people think that dependency injection libraries are fairly simple, right? And then it's
Yes.
kind of like, okay, well, here's a dictionary, and
And
here's the type I'm looking for, and here's the thing that makes it, and I'm done.
yes.
Um, when you start worrying about things like re-registering things, like if you want to do previews, you're doing testing or something like that, um, that can be a thing. If you start worrying about caching and supporting those sort of things, and that adds the complexity of it. If you start worrying about trying to work in a multi-threaded environment, that adds a lot of complexity to the thing. And all of a sudden, the thing that you thought was like 100 lines of code is now 1,000 lines of code or more,
Yes.
because you're trying to solve all these instances. Um, Factory at its core is a very, very simple thing. I just added a bit of, not complexity, but a lot of additional functionality to it that makes it a lot easier to do application previews. It makes it a lot easier to do doing testing, when I want to do unit tests and so on an
Yes.
application. I added support for doing things where I want to do custom injections if I'm doing UI testing where I have separate builds, but I want to do different kinds of tests on the same build.
Mm.
And so there's a lot of support on the development side for doing stuff as opposed to just, you know, here's the stuff that you need when I'm running the application.
Yes. And maybe that come to another thing, what we call the graph dependency, because when we inject something that service A depend of service B, C, D, and also service B depend also of service A, and we have this what we call cyclomatic dependency between instance, etc. And how DI container can detect this kind of problem, because this is problem in the conception first, that we have service A depend of B and B depend of A. How we can detect this, especially when we resolve the dependency, and how factory or resolver can detect what we call this kind of cyclomatic dependency, or directly or indirectly, because we have this kind of A depend B and B depend A, or the kind of the second example of A depend B, B depend C, C depend A. And especially with the problem that with when we have the property wrappers, we use this kind of property wrappers to inject dependency. How we can detect this kind of problem in our application during maybe the runtime, or there is some exception that is running when we have this kind of problem.
Okay. So there's two things you asked about. So
Okay,
yes, there's a graph scope,
graph scope. Okay,
and that's actually kind of the default thing that it uses when it's resolving. And it's hard to give a good example of that, but if I have a thing and that thing supports multiple protocols,
okay,
and I have some service that wants to inject both of those protocols,
okay,
then I want this thing that supported both of these protocols. I want the same instance to be injected as opposed to creating a new instance for each one.
okay.
So the graph scope basically is keeping track of what's getting requested.
Yes.
And if it seems the same, if it sees, it's sort of like a very, very, very temporary cache that exists while I am doing a single resolution. And then when that resolution stops, that cache goes away.
Okay. But I
Okay.
didn't understand why we need to have this kind of specific graph scope. Maybe we have some property in our in our container that have this information, like a dictionary that give us information that A depend of B, C, D, and B. Why we need specific scope to detect this kind, to create what we call for my point of view, I'm not an expert, but I think that uh, uh, we don't need to have this kind of scope. It's only simple property in the container that give us information about what we call the graph dependency. I don't know what do you think about my vision about that. Why we need
Um,
this kind of graph scope?
basically, it came about because when I did Resolver,
Okay.
I was trying to get the same behaviors that we had in Swinject.
Okay.
And Swinject has graph as its base dependency.
Okay.
So if I ask for something and I've already made it during the same resolution, then I give it the same thing.
Okay.
Okay. And
Okay.
again, you start seeing that when I have multiple protocols attached to the same object. So, maybe I've got a manager for users and I've got multiple protocols attached to the same repository. And I want the same repository each time I ask it.
Okay.
Okay. So
Okay.
that was the default. If you are wanting unique instances, then, and you know what's going on behind the scenes, then that's where you can annotate your factory and say, hey, I want this to be in unique scope so that every time it's asked to give it a new one. Don't use the graph.
Yes.
Okay.
Okay.
So you can override the behavior. So a large reason why there's a good reason why it exists,
Okay.
but a large reason of why it exists is that factory inherits its behaviors model from Resolver, and
And
Resolver
reserve
inherited its
from Switch.
behavior from Swinject.
Okay. 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 I
So
understand.
it's traditional.
It's tradition. It's but in
I'm not saying it's a good tradition, but it's a tradition.
okay. Okay. Yes.
Um,
We
you could
actually.
have done it. I mean, you could fake it behind the scenes if you wanted the same behavior. I mean, and that's I was going to say you could use shared, but that could be an issue. So anyway, yeah.
Okay. No problem.
Um, not thinking.
Okay.
So this gets to another thing. So cyclic dependencies,
Yes.
which was another part of your
Slightly
question.
different. Yes. Yes.
Um, and that's just sort of a system where, maybe I have A and A imports B and B
Yes.
imports C and C imports A.
Yes.
And now
So
we're
on.
down this chain again. Um, if you're doing it in code, the code would complain, right? The code would say, well, this initializer takes an instance of B and you're trying to make a B, and well, that's one instance of A, and I can't.
Yes.
But when you're doing the DI systems where you're doing these requests ad hoc, so to speak, you have to figure out some way of looking for that. That is the one point where both in Resolver and in Factory, you can get to the point where you've got a runtime situation where somewhere in that chain you did a cyclic dependency and you need to check for it.
Yes.
Factory has a not inconsiderable amount of code that was written during the debugging phase to check for cyclic dependencies.
Okay.
And it basically is building a graph of this request. But it's kind of, there's a lot of different ways to do requests. And, we actually had a discussion on this dependency injection system that you were making
Yes.
about, you had one way of giving it a request as a parameter, but you had another way of making the same request as a property wrapper.
Yes. Yes.
And
The
so
problem
both
with
of
it.
them ended up doing the same thing. And so how do
Yes.
you detect these chains?
Yes.
And um, I think the solution that I ended up on was just sort of a heuristic where if I keep asking for the same set of things, and I've done that over and over and over again, then at some point it just stops and says, hey, we're in a cyclic loop here. You need to
Yes.
figure out what's happening.
Yes.
And the depth of that chain can be adjusted if you've got some reason where you're doing like 1,000 dependency layer deep system. But in most cases, it works fairly well.
Yes.
Um,
And for
yeah.
your I think that you have to use it what we call recursive look, and this kind of okay, we can do speaking about what we call detect dependency, because in my little framework I use it what we call depth first search algorithms to detect this kind of. But I'm not very confident of my solution. But at this time, it's it's good, but it's not the the main or the for me it's not very appropriate to this kind when we use the property wrapper dependency Spark DI, as we discussed in the GitHub project during preparation of the first version. And for my point of view, it was a good solution to use DFS, the deep first search, to detect this kind of problem. And you have, as you said, more complicated system to detect this kind of dependency, especially because you use what we call the scope, graph scope, that I didn't use. I didn't have this kind of graph. I have what we call property graph dependency, simple graph dependency. By the time maybe I discovered that your point of view, I think that it's more uh, pragmatic about but this is only my vision about how to detect. Maybe there is other solution to detect what we call cyclic dependency in our graph of dependency, but I need the time to check that and to understand, especially for how why we need to maybe not use DFS and use other solution, or to integrate graph scope to Spark DI, etc. But Spark DI, it's not our topics.
Yeah,
Maybe
and
we,
just because I was going to say one thing there, just because something, the problem with trying to build a graph is figuring out what's in the graph and what isn't. And
okay.
so, just because something has been asked for before
Mm,
doesn't mean I'm necessarily in a cycle.
okay.
Right? My analytics library I keep going back to. I could have a
Okay.
whole bunch of things that keep asking for this analytics library. So I've made that
Okay.
request up that tree, but just because I'm requesting again doesn't mean I'm in a cycle.
Okay.
Everybody's sharing
Yeah.
the same.
Okay. 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 You correct my understanding of what we call cyclic dependency, because I understand that every time the kind of example that you share, A depend of B, B depend of C, C depend of A. If we have this kind of cases, we have a cyclic, and that's a problem from my point of view. But I think that's not the case for all time. Okay, okay. The kind of analytic, for
No,
example.
it was a. I'm sure that if I sat down with it, I could come up with yet another way of doing it that might
Okay.
be a better, have a better analysis. Um, but from what I've seen, again, our dependency graphs, usually tend to be, 5 or 6 or 7 or maybe even a dozen things deep. I've got to the point where I'm down to 1,000 iterations of this thing, and I
Okay.
keep seeing the same patterns in this iteration, then,
Okay.
like I said, it's a heuristic solution.
Heuristic solution. Okay. Yes. Okay. We come to another part of our discussion about DI container dependency injection, what we call data races, especially for cached scope, and what we techniques like mutex, semaphore, to detect this kind of data races, and to not to detect, to avoid data races in our DI in our framework. I think in Swinject, they are usually based on using mutex to protect reading and writing in the container. I don't know. In factory, you have the same systems to protect. Spark DI, there is actors to do that, using of actor, etc. But there is. But what do you think about, first of all, why we need to protect from data races? In which situation we need to protect our the container? Uh, from your experience, what do you think about that?
Okay. Um, so in a lot of cases, if I go back to my very, very simple dependency injection system, I
Okay.
register a bunch of things and then I ask for them.
Yes.
As long as I'm doing that, I really don't have a problem,
Yes.
right?
Okay.
Because the registration phase is separate from the execution phase.
Mm.
And all I'm asking for is this thing to give me what it says it can make, and it does so, right? So there's no races there.
Yes.
Um, one of the complications that we can get into is if I'm doing caching.
Mm.
Because if I'm doing caching, then when I ask for something, it's going to look in the cache for it. And if it's not there, it's going to make it, and then it's going to put it into the cache. So that point where I'm modifying the cache could be a problem if I'm in some sort of data race, if I'm doing 2 requests for the same thing at the same time somehow,
Okay. Yes.
right? Um, so then these areas of the code want to be protected. Uh, it's not, again, it's not a common thing, but
Yes.
the problem with doing a dependency injection library is that you really have no clue about what uncommon things people are going to do with your library.
Yes.
And so, again, if it doesn't protect against those things and it crashes, then that looks bad in your library, and they'll throw it away and find something that works better, right?
Yes.
Factory basically protects its chain with a recursive lock.
Yes.
And it's a recursive lock because if I asked for something and that thing needed something else, then that resolution is going to happen again. And if that thing needs something else, then another resolution is going to happen again, all in the same thread. So it's a recursive lock. It's
Yes.
basically saying, I don't mind if you keep asking me for this as long as everybody's on the same thread. If you're not in the same thread, you're going to get blocked until until the lock is released, right? So that's a solution to the problem. Now, I have seen some solutions
Okay.
that are using actors,
Okay.
and that is Apple's newest, latest, and greatest solution to concurrency and preventing these kind of things, right? So if a request is isolated to an actor, then I can
Yes.
only have one going through at the same time, and I'm good.
Yes.
And that should be working well for recursive requests. And again, we're good.
Yes.
The problem that I saw, and I thought about switching, but then I saw the problem that I thought with actors was that I have to make that request from an isolated context.
Yes.
Right.
Okay.
And if I'm initializing my application and I'm in a non-isolated context, I need to grab my analytics service as an example. I can't throw up a task and await for it easily. I say, give me what I need now because I'm in a procedural flow and I need it to say that we're launching the application.
Yes. It's not asynchronous.
Yeah. So using actors and so on is a great thing for solving a lot of their concurrency problems, but it assumes then that you have the ability to break things out into tasks to make those requests.
Yes. Yes.
And in a DI library, I don't often have that luxury.
Okay. And also you need to pass by the new concurrency. Everything, it's await, it's when you register, when you resolve all these things. But I think that people like to have this kind of swiftly new code using await, etc. I understand that for that using actor, um, it's much better to secure reading and writing because everything it's protected by a cached mutex system created by Apple, isolated this kind of island. Everything it's an island and isolated from the others. And but we have this problem, maybe the problem that that all the that for my understanding of dependency injection, that this kind of resolve should be synchronized, not asynchronous. We give me this instance that should not be have a lot of time to have this information. It's not a call to where a session or something like that. It's it's something that give me this instance, and also this instance have this dependency, and it should be in the main thread very quickly. I don't know, maybe when we okay, I have used this kind of dependency injection framework, and I have used Firebase to install Firebase, set up Firebase, which is in the app delegate. We should launch this kind of things. There is no problem until now. I speak with Spark DI, but I'm not confident that all things could be great when we resolve all my dependency. I need to make what we call heuristic test things, so something like that to be sure. But I'm not confident that using actor maybe caused some problems for some kind of dependency. I don't know until now. uh, it's in term of quantity of code, there is no mutex, no something, no recursive loop. The code it's much simpler using actor, but don't we simply now using the now until now.
It it
Okay.
it's simpler on the backside, and I mean, if you're using locks,
Okay.
then you have to be careful about the lock,
Yes.
right? And you want your lock to be as around as little code as possible
Yes.
from a certain point of view, because you want to be in and out and so you're not blocking,
Yes.
right?
Yes.
Um, that said, as the author of a library, it's up to me to make sure that I'm following those rules,
Mm.
right? So it's you're trusting the author to be doing the right thing, and to me, not having to is to run something in a task and not having to await it to get the result I need is offloading the complexity that should belong to the library
Mm.
to the user.
Yes.
Because I can't simply say, give me what I need. I have to say, oh, well, here's a task and here's that I'm going to wait for it. And I've
Okay.
complicated
Makes
my
sense.
call site to say, give me what I need.
Okay. Okay.
Um,
Okay. Okay.
and I'm going to go back and reiterate something I said earlier, I think, in that a lot of these times, these concurrency issues are not something that happens 99% of the time,
Okay. Yes.
right? I mean, if I'm making a view model and my view model needs three things and those get injected, well, and my view model is attached to a SwiftUI view, then I'm on the main actor. My initializer is on the main actor. It's talking to the state object and it's on the main actor and it's getting its stuff that it needs from the resolution. I mean, all that stuff is
Yes.
synchronous anyway.
Okay.
And all that stuff is single threaded anyway. So I'm not going to have problems in that regard.
The percentage of having this problem of data races, for if I understand you, it's not the reason to create all our DI container based on actor.
I
If I
wouldn't.
understand, it's okay. Using this kind, okay, I didn't have data races every time. Why I need to create to declare our DI our container as active? I'm not confident that I maybe I have some system to like mutex, recursive look, etc. It's much better for me to have this kind of system, okay, and my client, people that will use my application will not be obliged to have something like task wait, something like that to resolve or to register their instance, and the code from the user of application it's much simpler than okay, I understand your point of view about that. Okay.
Okay. And if you
Okay.
look at the code, if you look at Refactory, if you look at Resolver, there's a lot of code there.
Okay.
But if you look at the code from the point of tracing in from making a request,
Okay.
you know, depending on what's going on, I mean, it can basically just be a few dozen lines of code going in and back out again.
Mm.
So yes, there's a lot of supporting code around things, but the actual execution is not going through all of that code. It's just going through, the part that says, give me what I need.
Okay.
And again, a lot of the stuff about data races and whatnot is not something that is the odds are of someone doing something where I'll tell you where it's more likely to happen. Okay. I'll tell you where it's likely to happen.
Okay.
The odds are during running an application that I'm going to spawn like a dozen different tasks, and
Okay.
they're all going to make requests to the DI system, and that's going to break something. That's low. There's not a lot of chance that someone's going to be doing something like that.
Okay.
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 Where I can see that happening is, and where I have seen it happen, is when people want to launch their application and they need to initialize a bunch of third-party libraries, and they throw each of those initializations out on a thread in order to compress the launch time for their library
Okay.
and the
Okay.
compress the launch time for the application. So when I'm launching the thing, and if these things behind the scenes are going out to the DI system and saying, hey, we need the networking system, and hey, we need the networking system, and hey, we need the networking system,
Yes. Yes.
then that's where you can see problems. But again, I haven't seen a lot of people do that either. I've seen a
Okay.
lot of applications, and a lot of people aren't doing huge multi-threaded tasking things, or they're not even doing a bunch of multi-threaded tasking things on their application launch. The trading application I saw did it, but that's because this is a huge financial institution, and they've got a lot of third-party things that they're integrating, and they also want to make their application friendly and reduce the launch time down to something that's manageable, so it doesn't take 30 seconds to launch the application, which it was, I think.
Okay. We come to the last part of our discussion with you, Michael. Uh, the evolution of DI container. Now, for your perspective, factory, what do you think about? Maybe there is evolution. Also, you speak about the new navigation SwiftUI that integrate this kind of dependency injection without using DI container or what you call the framework. Uh, what especially opportunity that come with using macro maybe in our I'm not fan of macro, honestly. Honestly, but I think that it's very very difficult tools, but to integrate in framework of dependency injection, maybe using property wrappers, something like that. It's much easy to have, but macro, I for my understanding of micro, it's not easy. I need to have your point of view also about that, and what kind of improvement that can be still made in factory from your point of view or uh, of uh, of dependency injection frame.
Okay. So one thing that's difficult with factory, I'll come at
Okay.
it this way, is if I'm doing modular applications, because the whole idea behind factory was that I went and created this thing that has the factory that returns what I need,
Okay.
and I have to be able to see it in order for stuff to work.
There is no assembler like SwiNject, something like that.
Um,
To models, something that we have for kind of models. Okay.
okay. Um, no, it's just how it works. The property has to see you have to be able to see the property to ask for the thing that you want, right?
Okay. Okay.
But if I'm in a module, and I need to use this thing,
Okay.
but that thing gets provided from somewhere else,
Yes.
then we've got some sort of problem. Then you have something that, again, has to happen during application launch that basically says, oh, you're going to want this, and I'm going to give it to you, so you'll have it when someone asks for it, kind of thing, right?
Okay.
So you do end up with some registration phases, but my solution in factory on that was to simply say that, yes, I'll make that available, but those things are optional,
Okay.
right?
Okay. Okay.
Because the whole idea behind factory was that it's compile time safe,
Yes.
right? And so you can trust that what you're asking for is going to be there. If I can't trust that what I'm asking for is going to be there, if it's going to get supplied at a later point, but potentially not supplied at a later point, then it's optional, right?
Yes.
That's the trusting part. I'm going to trust. I can't trust that you're going to give it to me, so I'm going to have to be able to handle it if you don't.
Mm.
Okay.
Okay. Okay.
Um, so that's kind of the thing that I saw with Factory, is that it's a little strange to use in a multi-module environment.
Okay.
Resolver was much easier in that regard,
Okay.
but again, Resolver was at the point where, well, give me what I want. Oh, you don't have it. Boom.
Uh,
It wasn't
um,
safe.
okay, but in SwiftUI, for example, there is the system of assembler, but all things that exist in what we call one shared container. And I think factory have one shared container. If you have one shared container, you can resolve what, despite that you have in model 1, model 2, 3, because we have one container for all the application, there is no problem. This is the kind now in our application, we have shared container and we have different models. When we want to, from module 1, to resolve a dependency that we have registered in module 2, for example, we only need to, okay, we have what we call the dependency injection abstraction models that contain this, the shared. We have created this kind of framework to access to our shared framework, shared container. In every time when we have in module 1, 2, 3, 4, you understand me? There is one shared container and one framework from dependency, what we call dependency injection abstraction, that contains the shared container. And if I am in model 1, 2, 3, 4, there is no problem. There is one container shared for all the models. And what do you think about this kind of solution? To validate my understanding, because this is my purpose to my team to have this kind when we have different modules, etc.
Um,
Okay.
the mm, I
Mm,
don't know how to go into this really well. Um,
okay.
a large part, I think, depends on how you structure your module application.
Okay.
And again, given some of the trading application that I worked on, um, was a huge application. There
Okay.
were 2 or 3 or 4 dozen modules and feature sets, and there were several layers of core modules and whatnot of functionality that could be imported, and there was cross-module communication that needed to occur. Um, but those sort of things are difficult to manage. So just I mean, you can have a single small container of things that I give to each module,
Yes.
but that module is going to want certain things as well.
Okay.
And it's going to be adding its own dependencies to that container.
Okay.
It's going to have its own view models, and it's going to have its own data fetchers, and it's going to have its own repositories, and so on. But sometimes it's going to want to request things across from another system, and it's how do I get that request? I can't make that thing because I can't see that thing.
Okay. But you are not.
But that's why the stuff was optional, right? I'm going to want something that conforms to this interface,
Okay.
but I can't make the thing that conforms to that interface because that's somewhere else that I can't see.
Okay.
You're going to have to edit that one.
Okay. I know that this is my purpose to have this what we call the shared instance container, and every time when we launch the app delegate we register it, and for because we have what we call, I don't know if you know, composition root to launch and to create all dependency in the to register all dependency in the main one container for the different module. We have dozen of modules. There is no problem until now. We have also everything until now. There is no problem with this kind of have one shared container, and at this moment I didn't have any problem because the things that I don't like in our solution that we have injection container point shared with it's which is a kind of singleton, and every time in every modules I need to call this to resolve or to register, and this is the thing that I didn't like very much, but I didn't find any other solution much better in my understanding rather than this have this kind of shared instance container, if we can say.
Okay.
Okay.
So this could be a time to talk about a little.
Okay.
I've done a new open source project, and it's called
Okay.
Navigator.
Okay.
And it's basically a SwiftUI based navigation library.
Okay.
And it's based on using navigation path and navigation stacks and so on. And a lot of people have done that. But there's a very, very heavy emphasis on being able to do things that other libraries don't, like managing deep linking into an application. So I can say that,
Okay.
user clicks on something and I want to launch my application and I need to switch to tab I need to switch to the profile tab, and
Yes.
I need to push another view onto the screen. And then from that view, I want to launch a sheet.
Mm.
And so, how did I manipulate all of that state to get to where I need?
Yes.
Right. Or I go down a certain ways and I need to go back to a certain spot, but I don't
Yes.
want to pass bindings and stuff like that all the way down the chain or so on. So how do I return to a specific checkpoint? And there's a bunch of things that it solves. But one thing that's in that code that I've been using this code as a playground for trying out yet another dependency injection concept.
Okay.
And it's basically a protocol defined dependency system
Okay.
where effectively you're saying, here's the protocol of the things that I need. Give me a container that matches that stuff.
Okay.
And some of the things that I already know how to provide. So I know how to, if I'm in a module and I need a view controller, and that view controller needs I need a view model, and that view model needs certain things. I know how to make that view model, but the dependencies for the view model have to come from somewhere else.
Yes.
So there's some protocols that are visible to that feature that are in the core. And then there's things that the feature needs that it has to ask from the application. But there's a contract there, right? So
Yes.
anything that's empty, the application has to provide.
Okay.
And it's sort of a container-based system, but basically it sort of builds these layers of protocols and these layers of protocol extensions. And then the application builds the core container and passes that to everybody, basically. And because it's up to the application to fill in the holes, anything that's missing, it has to fill in. Otherwise, it can't create an instance of that protocol to give away.
Okay.
So it makes a lot of things. It solves the compile time safe problem. It solves the optional problem, because it doesn't has to be optional. You have to be able to give it to me. Otherwise, you haven't conformed to the protocol.
Yes. To be optional. Okay. To be optional for okay. Why it's optional? It's a dependency. It's an element of that our dependency need. Why it's the optional, and at this moment there is some philosophical.
Okay. Well, that goes back to the factory thing. The factory thing is that if there are some things where for this feature has to have something that says at runtime you need to give me an instance of this thing.
Yes. Okay.
But I'm not at runtime yet, and I don't have an instance of this thing to put into the factory method. And so I have no choice but to return, I think, either a mock, maybe I could put a mock in there.
Okay.
Or just nil. I don't have it yet. And it's going to be up to the application to give it to me so I can give it to you when we run the app.
Okay.
Okay. And that's why it's optional, because it's not there yet. And I'm going to have to trust the application to give it to me. But the whole reason factory existed was because I didn't want to have that trust issue.
Okay.
Right. So if you didn't give it to me, I don't want to blow up.
Okay. There is no crash.
So it's optional because I'm trusting that it's going to be there, but I need to be able to deal with it if it's not.
Okay. I understand. Okay.
But yeah, this container, this new system basically uses containers and environments and stuff like that to try to pass things around. And it's been working pretty well. So I'm not saying about to retire a factory, but
okay, I will check this project.
It's going to need like a boatload of articles talking about it or something, though, because you sort of have to walk through the rationale about how you define the protocol and how you define the layers of protocols and how you define default things that I know how to make, but depend on other things.
Okay.
But that's getting outside the scope of, I think, where we're talking about.
Okay.
But it just kind of illustrates, too, that a lot of these solutions are never ending problems, right? And things evolve. And I'm going to go all the way back around to the start. Things evolve given the tools that we have.
Okay.
Right.
Yes.
So back in the day when I had, views and view controllers and all these hard references to objects, maybe my architectural solutions were things like Viper, where
Yes.
my primary mechanism was delegation. So I
Yes.
hardwire all these things together, and I use delegates, and I talk to the delegates, and that's how stuff happens,
Yes. I
right?
understand. Okay.
Um, but that sort of thing doesn't work today with SwiftUI because my
Mhm.
views are not reference objects, and I
That's
can't maintain links to them, and they're being created and destroyed all the time anyway. And
mhm.
so those solutions no longer work, and we have to find new ones. And the same thing with when I talked about Resolver. Um, Swift gave me this brand new toy to play with called type inference. And because I had that, I was able to get rid of a bunch of things that I didn't need before.
Okay. Okay. I understand you much better now. Thank you, Michael, for this great episode about dependency injection. Uh, I think that I have learned a lot from your experience about dependency injection and how software development should software developer should think about when they try to create framework for dependency injection. There is a lot. Okay, we should to understand all these concepts, and by the time, by the evolution of Swift UI, etc. This is at this time we have the need to something like the new navigation container project that you spoke about, factory resolver. There is usually a reason to have a DI container framework. And for me, it was a great episode from the second season of Swift Academy. And I give you the to finish the episode. What kind of advices for developers that to think about dependency injection? Kind of books that you recommend to the community, maybe something like that.
Okay. I don't have the one. I mean, there's the one big book on dependency injection, but I don't have the name right off the top of my head.
I think dependency injection principles and example in .NET.
Yep, there you go.
Yes, yes,
Yeah, I was trying to find that. But that's a big read, and they talk about a lot of things that you need to think about. One thing I did notice in that particular book is that they sort of have the viewpoint of I think about doing like web services and that sort of thing, and
yes,
back end kind of things where I sort of create my whole service all at once, and that's not quite as dynamic as mobile applications and so on, where
mm,
I have different tabs and I'm creating new views as I'm going along,
yes,
and I'm creating these new instances where I need to ask for things, and that complicates trying to do stuff like composition root kind of solutions and so on. But I highly recommend it. Actually, I will tell anybody that if reading good books on programming will enhance your programming, because you're just exposed to things that you hadn't thought about before, and you can do a lot of stuff with seeing podcasts or watching YouTube videos or so on.
yes,
But um, going through a book where you're following someone's thought process as to how all this should hang together
yes.
helps a lot.
Okay, great. Thank you, and see you soon. Thank you. Bye.
But